Thanks for interest in learning about RISC-V. My presentation today is going to cover how you can all be part of RISC-V, how you can all help us develop RISC-V. And to do that, I'm going to show you what we do and how we do. So you can find maybe some good places to get started and help us. So you do not need to be a spec writer or a specification author to help us drive that. So my name is Rafael. I'm a technical program manager within RISC-V International. So my key responsibility is to ensure that we all work together, in a really community fashion, and we deliver the specifications. So you're going to see through the presentation the number of specifications that we have on flight, and the number of technical committees, and the number of companies that are part of RISC-V, and manage them all to ensure they can collaborate effectively is a really interesting job. So let's get started then. Moving forward, so cell phones, cars, laptops. And in fact, I have a RISC-V based laptop here near me. Wearables, data centers, AI workloads. RISC-V is going to be everywhere. In fact, we start to see that growing in the market with new solutions coming up. As I mentioned, laptop here. There's tablets. There is data center servers being made. So there's a lot of things happening, especially because we see a huge growth on key verticals where RISC-V is being used to solve specific problems. So from embedded to HPC, they are leveraging RISC-V as the open standard to ensure they can solve their problems easily and faster. And this is a research from a company called SDH Group. They predict by 2031, RISC-V is going to account for a good number of the market share, from consumer, like laptops and other stuff, to networking. RISC-V is growing quickly in all those areas. Why RISC-V is growing? Why RISC-V is becoming so popular as an ISA? Especially because RISC-V, behind RISC-V, there is the need for hardware and software co-design, where you can leverage an ISA, customize your software for that, or tune your software based on your hardware design, and focus on selling the end product of your, the end product that you are willing to ship. So this is only possible. This is only, we see that growing quickly because RISC-V is an open standard. RISC-V is not an open source implementation. RISC-V is not open source code. It's an open standard. And as an open standard, that means that we build that collaboratively with multiple community members, with multiple hands, in a transparent fashion. Of course, as we are dealing with community, when I say community, individuals with different goals, that usually takes a while to get consensus. But that helps us to move forward in a really high quality level, because at the end of the day, the best solution is going to be the best that, let's say, solves everyone's problems in a best effective fashion, considering the state of the art of the ISA, of an ISA development. And also adopt an open standard, it's going to be hard for you to get back to a private solution or closed solution. We have seen this happen in the history before, right? So here are some examples. From network to compilers and databases, and now we see that happening on ISA. So we have the proprietary ones like x86, ARM, IBM 360, PPC64LE, that's power. And now we have an alternative like RISC-V. It's the open standard for ISA. And that enables you to do basically anything you want. If you want to understand a little bit more of the power of the open standards and why they are important, you can take a look on the latest report by the Linux Foundation that was updated this year on open standards that help you to understand their impact and how they are shaping the world that we are living in. And also adopt an open standard that, in the case of RISC-V, there's no royalty, it's royalty-free, you do not need to pay to use RISC-V. That start to enable a lot of opportunities for individuals, communities, governments, companies. For instance, for a country, RISC-V today means tech sovereignty. So if you have your CHIP Act, like you see happening across the globe, you understand why they are adopting RISC-V. They want their let's say, autonomy and independence on designing their or owning their end-to-end supply chain on semiconductor design, and at the end of the day, producing that course. For multinationals, RISC-V allows them to control their roadmap, which means that they understand when, how, and what they're going to ship without depending on other companies, for instance. For researchers, it's the freedom to do anything you want. In fact, if you take a look on the ACM or other places where you can find papers on computer architecture and ISA, you're going to see a lot of them are about RISC-V or are using RISC-V as base ISA, because that gives them the freedom to do anything they want. Just a matter of downloading the ISA, getting maybe one student or one researcher, and start doing anything you want. So that gives research the freedom to do anything. And for startups, it's a green field. Once you understand the chip design and you can customize software, you can start solving problems that maybe prior RISC-V was not possible or was not cheaper to solve. And I talk about what's happening across the globe, and then this helps you to understand what's really happening. So if you look at Europe, there's a major investment in RISC-V from different sectors: automotive, the aerospatial or the space, HPC. If you take a look on what the Barcelona Supercomputer Center is doing with RISC-V, that's going to give you an idea about how deep they are investing in RISC-V. Same happening in India. The RISC-V became a major, let's say, part of their strategy for semiconductor sovereignty. China embraced RISC-V. We know that. We hear the news about that. Also, countries that we were not expecting that to happen, like Brazil. Brazil is investing in RISC-V a lot, which means that that's part of their government local programs, I'd say, to form and educate engineers on RISC-V. So it's spread across the globe. There's, I'd say, no major initiative that is not considering or have not considered adopting RISC-V at this point. And we are moving forward fast. This year, RISC-V celebrates 15 years. So if you want to understand the full picture and the whole history from the very beginning, scan this code or go to our website, and you're going to have a huge content and a huge blog post describing every single step or every single milestone that happened. We are moving forward faster. So in less than 15 years, we see a lot of products that are capable to face or compete with what we have in the market already. So it's not a matter of when RISC-V to start to take over more market, but when. We are moving faster. We are moving quick. And we are doing bold moves every year. In the last 2 years, we ratified over 40 new specifications. And we continue to add more to the base ISA, so RISC-V can be more capable, and you can start to exploring more and more scenarios that was not possible before. This is numbers, so we like to show some numbers so you understand what's going on. The same research that we saw at the very beginning shows that by 2021, and here we're talking about SoCs, no more talk about cores. So let's say it's about, I can't read here, that's bigger, 25.7% of the market is going to be RISC-V. So that's, it's not us, RISC-V International, saying that. It's a research company mentioned that numbers and showing that it is growing quickly, and that there is evidence that this is growing quickly. But this talk here is not about selling RISC-V. It's not about telling you that RISC-V is growing, RISC-V is becoming the most popular ISA. It's about how you can help us make that. What are the opportunities for engagement? What you can do. If you're not a specification author, you're not willing to design an ISA, what areas you can help drive? What areas you can jump in, raise your hand, and start collaborating? So from now on, this can be a more iterative session. If you have questions, just raise your hand, and you can ask. But I'm going through a bunch of materials here to cover how and describe how we make RISC-V possible. So RISC-V is specification. At the end of the day, it is a PDF file that is available on GitHub or in our website that you can download and pick some open source EDA tools and start doing your chip design. But to achieve that goal, and let's say, to get the PDF up to date in a state that can be consumable, there's a lot of work that needs to be done. I'm going to show some numbers about how long it takes to get one specification ratified and the amount of work that's needed to make that happen. And you're going to understand why we need help. Why collaborate with RISC-V is pretty much becoming I would say, a kernel maintainer, if you will, because there's a lot of things to happen there. There's a lot of things that you can touch. There's a lot of things that you can help drive. First things first. RISC-V is made by the community for the community. What that means, there is no RISC-V if there is no individual or group of individuals willing to make things happen. We are big from the number of community participants point of view, but we really are focused on getting the best possible ISA that the community can use. That's why we see a lot of engagement. That's why you see a lot of people passionate about RISC-V, a lot of people pushing RISC-V, because it's built by the community. RISC-V gives you all the opportunity to participate in something that was not possible to do before. I mean, can you raise your hand like and say the number of open source ISAs we had in the past that opened a bunch of opportunities for you all to collaborate and design an ISA? So yeah, pretty much none. So now we have the opportunity not just to help design an ISA that's going to last at least for the next 50 years, we hope, but also to help build that whole ecosystem that composes RISC-V. It's not just about, again, an ISA, the specification. It's about making a broader ecosystem grow healthily so everyone can take benefit from that. And there's a lot of opportunities. There's a lot of opportunities. So first things first, before we talk about members, what we do, as a really quick summary, we have the base ISA. Everyone that we're going to talk about here, everything we're going to talk about here is about the base ISA or the main ISA. We cover that, we developed that, we ensure that it's consumable and everyone can work on that. Because why we do that and why we have people collaborate to make that happen? Because once the base ISA is really solid and reliable, we have opportunities for different paths. For instance, here, someone can decide to go to the fully open path. I have my company, or I'm a researcher. I want to do my open core and make that available to everyone and distribute that. You can do that. You do not need to pay anything for us. Or if you are a company and you have seen an opportunity to solve a problem that no one else was able to see, so you can grab the same base ISA, the same high quality ISA, and do your own customization and sell that as a product. So there's no limitation about that. And even you do not need to tell us what you're doing with RISC-V. We're not going to ask you what you're doing. Just do the work. Just try to address a need. And that's possible, and that's why we see a lot of companies joining RISC-V, that have joined RISC-V recently. So this is just a screenshot, or the premier members of RISC-V. There's a lot of well-known logos here. And they are, which one? Yeah, TenStore, they are a member. They are, but they are, I'm not sure if they are premier or strategic member. These are just the premier members. So they are the members that are seated, they have a seat in the board of directors, essentially. So you see here that we have a good number of companies. There's a mix from companies from different places in the world. The majority comes from the United States and China, but also we have the Brazilian government here. And we have the European company called OpenShip. Where is that? I don't know where there is. There. So it is distributed. But we have a lot more on as the strategic members and community organization and community individual members. So I believe if you look at our main list, we have over 4K emails of individuals that are contributing to RISC-V or are part of RISC-V today. But to make this work, so how that works, first, every company here does have their own goals, and they want to achieve something within RISC-V. What we need to do is to ensure that they can do that, achieve that by collaborating with others. To make that happen in a way that's healthy, we need to organize them. We need to structure them in a way that they can work together. And this is how we are organized. This is a high level about our organization as an entity, I would say. We have the board of directors. They drive us from the business point of view. We have the technical steering committee. They drive us from the technical point of view. And below the TSC, we have what we call horizontal committees that are driving major advancements on those key areas here, major areas, I would say. Under each HC, we have a lot of technical groups, technical or task groups and special interesting groups. And then we also have 2 special, let's say, committees here that are privy spec and the unprivy specification. Essentially, in those 2 special committees, you're going to find the creators of RISC-V, because they are kind of, everything that we do here affect what they need to touch at their side. We have a technical committee, architectural review committee. We have, myself and all my colleagues are part of this staff that helps support them all. And also we have now, that's under, let's say, consolidation and under formation, the certification steering committee that's going to handle RISC-V certification. So this is how we can manage it to get them to work together. They understand that there is a structure. They understand that we need to elect, so each horizontal committee here does have a chair and a vice chair that should be elected. There's a process for election, there's a process for voting, there's a process for everything. So if you want to apply for a position to lead something, so you need to put your name there and ensure that you do a good job in the community, so the community recognizes you as a key member to be able, to put in a leadership position. So I'm not going to cover the details of the policy. We changed the policy this year, but this is how we organize and how we are able to work together. So today, we have around 22 special interesting groups in RISC-V and 24 task groups. That number is going to grow this year because we have more 15, is a mix of task groups and 6 that are under development. And yeah, that's going to grow. So all of those areas, what we have here that I would like to highlight. Those are the names, the kind of the key areas that we are working on. But we have some important ones here. So starting with the task groups there. You see that we have highlighted the attached matrix, integrated matrix, and server platform and security mode. Those are part of our priorities this year. What's going on the matrix side? So we all understand that on this AI world, everything that happens to handle inferencing and training requires really good matrix operation. Because at the end of the day, you are doing matrix multiplication there, or matrix operations when handling with AI. With RISC-V today, we have a bunch of experts on that. And they come from companies like IBM, Ventana, NVIDIA. They are all collaborating on making the best possible instructions to handle matrix operations. So they're putting all their heads together. That's taking almost 2 years. Just a discussion about how to make that happen and how they can make this become a reality. So right now we have 2 groups handling that, attached matrix and integrated. The difference here is like integrated is going to use the RISC-V vector instructions. Not directly, because now we have a third technical committee, that's the technical group that's going to be called vector matrix extension. That's going to really be based on RISC-V vector extension. And we have attached, which is a kind of external, how we can build an external accelerator, essentially.
Are you taking questions? Or?
Go ahead.
Okay, so you know NVIDIA, right? GPUs, it all compiles down to CUDA.
Yeah.
For these, RISC-V vector operations, how are you going to generate code? Is it going to be OpenCL or? Yeah,
that's again, RISC-V is built by the community. This discussion is happening right now. What's going to happen? They understand that we need a common software interface to handle that. Otherwise, it's going to be a mess. So what that's going to be is not yet defined. So maybe it can be OpenCL, maybe it can be other, maybe a new totally new framework, whatever, but it's going to be defined yet. So that's why maybe we need someone that understands this scenario and can highlight those issues to the community so they understand what should be done. Again, there is opportunity for that engagement. So if you are an expert on that area, maybe you can raise your hand and say, hey, maybe you need to do this, this, and that. Otherwise, that's not going to work. So anyway, yeah, that it was highlighted, I'd say, in the last 2 meetings that the software consideration, the software definition about how things can work should be part of their ratification plan so they understand how to make that work at the end of the day. So on the SIG, here the clear difference is a task group delivers a work and make that work happen. A SIG can do an investigation. So what are the gaps? What should be solved? What do you need to do? And when a SIG understands there's a gap, they can request TSC, the permission to create a task group. And then we go through a process that usually takes one month, essentially, or more within the new policy, to create a new task group. But anyway, about the SIG, I highlighted some here that I believe are important for you all to understand. AI/ML, called that critical. We have 2 SIGs, one AI/ML to handle AI/ML from the ISA point of view, and we have another SIG for AI/ML to handle AI/ML from the software point of view and workloads point of view. The documentation, that's growing because we need to create an ISA that's consumable and that is easy to consume, right? And how we can produce the best ISA possible, that you as a developer at the end of the day can understand how you can get the sentences and understand that. And what you understand is what helps us to drive. So we have a good number of people focused on how to get the documentation done for RISC-V. And they are discussing, just to give you an idea, they are discussing what a given word means. Why should you use that word, not that? So, because a single word can make a huge difference in how you can understand a single sentence, maybe lead to a wrong implementation, depending on the scenario. Anyway, we have the profiles. We're going to talk about profiles later, because I need to hurry up a little bit on this one. But for instance, we have a bunch of specifications and a bunch of new extensions that get ratified. How you can consume that easily? Usually we bundle them in what we call profiles. So let's say last year, we ratified 2 profiles, RVA and RVB. As part of RVA, we have a bunch of specifications that are mandatory, a bunch of optional specifications. So when you want to implement something from now on, you can just target RVA 23, for instance, that ensure compatibility. And for instance, from operating system point of view, we can have Red Hat, Canonical, SUSE, all supporting RVA 20 or RVA 23 in order to ensure they have compatibility. So that helps a lot from maintainability and development point of view. So moving forward here quickly. This is just to highlight what it takes to build a technical committee. It's going to take about 1.5 months. Tell you the story in less than 1 minute. If you have an idea, anyone can propose a new technical group or technical committee, as we call. If you have an idea, you need to raise your hand. You need to write down what you want to do. So you need to go to TSC and say, hey, TSC, you need to pretty much write down your elevator pitch. TSC, I believe we have this problem to solve, and this is what I propose doing. Do you approve? Do you accept my proposal? And anyone that's a member of RISC-V can do that. And then we go to a bunch of process, like presenting that, getting the formal approvals, getting the community review, the community review about what you're proposing. Make things, then get the last approval is the board of directors approval. So every approval takes usually 2 weeks. So it's usually 1.5 months to get this going. And then once your task group is in place, that takes a little bit more time until you are operational. We are doing that to ensure that every time you propose something is really meaningful to RISC-V. Because in the past, we had a lot of technical committees that were just in place, but not really delivering. So not going to, again, not cover all details here, but you understand there's a process. If you want to join RISC-V and propose something new, understand that's not going to be quick. If you come up with something that's already done, understand that's not going to be accepted out of the box. Like, we have cases where some try to offer something that was already done, Usually that goes to a bunch of approvals and reviews, so there's a process, and that takes a little bit of time. The same for specification. The specification lifecycle takes a while. Here again, we have pretty much 6 phases, and the specification from the moment that gets approval and start getting developed takes a lot of time. I have an example here. Not me. We have a bunch of tasks. I'm going to cover in the next slide here. But if you are willing to join RISC-V and develop a specification starting today, probably you're going to ratify that by July next year. That can take over 1 year. There's a lot of variables that affect that, like the number of time a given member can dedicate to that, the number of resources a company can help put to make that move forward, and the priority. So the number of people that are contributing to the discussion. As more people we have contributing to a discussion about defining something, more time it's going to take. Some can see that as a negative or a bad side or a bad behavior, but what we have seen, in fact, is like when a broader discussion happens and that takes a little bit more time, the end solution or the end proposal is way more solid than if you need to do something, if you end up doing something really quick that needs to be reviewed and maybe changed. Remember, when you do a specification, at the moment that the specification is frozen, essentially, companies can start to play with that to create products. Imagine if we change that after the freeze. Imagine if we change that and a company is already implementing that. Of course, you can debate whether or not a company should be doing that, but anyway, takes a lot of time. And during this process here, there's a bunch of activity that happen. But before touching that, we also have, it's a software, right? It's not software, it's code at the end of the day. Everything we do is on GitHub, so it's open. This is the workflow for the main ISA repository. We have our main maintainer, that's Andrew Waterman. It's pretty much our Linus Torvald, if you will. He is one of the 2 students that started RISC-V and pretty much maintains this working and maintains the ISA really consistent. So you know how forking works, how merge works, how that process works. So this is how we drive that. And again, when we talk about RISC-V, what happens as a collaboration, as a work on the development? We have the base ISA, the core ISA. Around that, we start to come up with new extensions to improve that. So we have the ISA extensions, non-ISA extensions. You can also develop your own custom extensions. We do not ratify custom extensions because that's what drives or what helps make the differentiation. But you can do that. There is the X kind of extension that you can make. When we have a good number of extensions, you can compose that in profiles that we discussed before here. And then those profiles can be used to implement and ensure consistent across different platforms and vendors. And we have, on top of that, the platform. So right now, we have the server platform under development. So that should be ratified this year if everything goes well. Pretty much that describes what a RISC-V server should have, considering the specifications, especially non-ISA specifications. And this is what we do. This is how things work on RISC-V, how we can see RISC-V from an external point of view, and how we evolve the development and how we make things happen. We start from the core, we add extensions to improve that, we group the extensions in profiles, and later we transform that or come up with platforms to make it easier for others to consume that. But now, how we can participate? Go ahead.
Back on the previous slide for your platforms, you mentioned the server platform is in works.
Yeah. Yeah.
Any timeline on those?
The server platform should be ratified this year. We have the automotive one that's is getting traction again this year because there's a real need for the automotive sector. We have one for the aerospatial. There are companies like, I believe, Airbus, front grade, if I'm not mistaken, that are willing to make that happen because there are some needs. There's some intersection between the aerospace platform for aerospace and automotive sector. But those 2 are starting, not going to get done this year, if I'm not mistaken. We have the microcontroller. It's not a platform, but initially it's going to be a profile. microcontroller profile. That's also starting. We are under discussion about their proposal of work for the last 2 months. So there's a lot of things change here and there. So what I can tell from timeline, it's hard to predict when something is going to get done. But what I can tell you right now is that we hope to get the server platform at least frozen this year, because we should have done that last year. But again, this is a community effort. We move as fast as the community wants us to move forward, and we can't push. So if you are developing that and I knock your door asking for hurry up, you're going to tell, so you're not my boss, so why are you doing that? So anyway, that's hard to predict. That's going to happen, but it's going to happen when the community wants to achieve that goal. We try to speed up that, but it's beyond what we can do as an entity at this point. But how to participate? We talk about that. So first things first, become a member. RISC-V made my members, you can only contribute to the main ISA, become a member. You can join as an individual member for free. If you're academic, non-profit, or individual, you can join for free. If you are a company, you can join as a strategic or premier, and there's a fee that you pay to join RISC-V. And do you need to be a spec developer or a spec author to really be part of RISC-V? No. Why not? So this is a really nutshell. You can select the SIG or TG, just join and start observing. If you have the necessary skills, you can start engaging to help them make progress. If you do not have the necessary skills, you can if you are just curious, you can join, because what the community or the technical committees with RISC-V are discussing pretty much is what's coming next. What problem I need to solve next. And if you're a student at architecture computer kind of class, you can have a deeper discussion on, about computer architecture happening in front of you here. So start to participate, engage, join the mailing list, see the conversations, share your opinions there, contribute to code on GitHub eventually if you want, and propose new initiatives. Again, there's a process that can take a while. But what are the more practical aspects of that? How you can, let's say, get your hands dirty and help us. Enhance RISC-V golden model via Sail. We have chosen Sail as the golden model, the language for writing golden model for RISC-V. So if you are really passionate about computer architectures and writing reference models, so you can help us improve RISC-V there. So there's a lot of opportunities to solve. There are a lot of challenges to solve on the golden model. So if you are a formal engineer that's willing to work on that, feel free to help us on the Sail. If you want to be a kernel maintainer or on the RISC-V side, we have few individuals there. We have a lot of opportunities on the kernel. So from optimization, CI improvement, for tests, writing new tests. So I run, this year, I run one mentorship for kernel CI. I got over 200 applicants for that mentorship, and I was able to select only 3. Then I run the second mentorship for the kernel CI, and I got over 100 new applicants, and I was able to select only 2. So there's a lot of opportunities to engage on the kernel and a lot of work to do. With the mentorship, I cannot do a lot because that lasts 3 months, but if you are willing to help us and willing to get on the kernel in areas that does not have a lot of people yet, feel free to help us on the kernel side. If you are more a compiler engineer and you want to get things done, maybe you can help us on the toolchain. We have a toolchain SIG that handles the work or discuss the work that should be done on GCC and LLVM. Again, there's a lot of optimizations to be implemented. There's a lot of bugs to be solved. There's a lot of we still need a flag like that you can compile without setting a huge string of code. Go ahead.
So you know the Linux device model?
Yeah.
So you know what happened with ARM. There's like device tree source and a device tree binary, and that's how, because Linus got tired of dealing with everybody trying to push ARM code for their board.
Yeah.
So you're in a similar situation.
Somehow, yes.
Right?
Yeah.
Everybody's got their own, spinning their own boards.
Yeah.
How are you going to deal with it?
We are trying to suggest, we cannot impose, but we're suggesting upstream first. We had companies complain about this same situation where they had a bunch of patches that were kept downstream because they were just enabling a board, and they were not able to really push that upstream because that was really specific, and that would not be acceptable for making that change. So again, this is another open discussion that's going to require some solutions at some point. We have, in addition to RISC-V, we have RISC, which handles the RISC-V software side. There are some discussions about the kernel that happens there and the contribution that happens there. So, but again, is in progress. There's no, we discussed, I believe, 2 years ago about getting a group like a TG to handle kernel so we could align the contributions and ensure everything that should be done in the same way, same fashion, but we didn't get that done. So again, it's an open, we still see that happen a lot with the major operating system companies like Red Hat, Canonical, and SUSE joining. That's become a little bit more, let's say, clear and simple from their point of view because they are working for other companies that requires that and they know how to do that upstream. But there's no easy solution for that right now, and we see that happening a lot. So if you will, you can talk with the guys from Deep Computing. They are here. They are the guys that produce this RISC-V laptop, and you can have discussion about.
That's a framework.
This is not a framework yet. This is one generation old, but you have the framework there. You can play with that. But anyway, no easy answer for your question. But anyway, if you are good on that, we need the help on that. So join the community and help it happy. Yeah, feel free to help us. Running up here, running fast. So if you want to help us write tests for RISC-V, you can. We need to write a bunch of tests, especially as we are pushing for the certification. So there's a bunch of tests to validate the extensions to ensure they work properly. If you want to do that, feel free to join us. Or if you just want to help us write better documentation, there's opportunity there. So everything that happens throughout the development is kind of a massive engineering kind of effort. Yes, we use Jira to track that. Do not blame us, but that's how we do that in a good way. So there's a lot of activity that happens. So if you are willing to raise your hand throughout the development of a specification lifecycle, you can help us. We do the two-chain contributions, the kernel enablement, QEMU enablement of virtualization, write the documentation. So there's a lot of work. There's a lot. We have a huge backlog on that technical debt because there's no enough hands to make things happen. That's why you do not need to be a specification writer to join RISC-V. You can just show up and share your best skill, either as a software engineer or a compiler, whatever you want to do. There is an opportunity for you all. In fact, there are a million opportunities for you all. There's a lot of opportunities. So I would say just show up, raise your hand, decide to do get involved, start contributing. So RISC-V is made by the community. So we need all you get involved to help us. Quickly here, to close, how you can learn about RISC-V. We have a bunch of training and courses. So they are all available on that GitHub link. We have listed a bunch of course trainings and courses that you can just grab. If you scan that code, you're going to get all the courses and education materials. Also, there's 40% off if you apply this code during this conference. More engagement opportunities. If you want to contribute in another ways, so you can help us and teach a course. You can provide a course. Usually we pay for those who write good courses. You can become a mentor or apply for a mentee as a mentee for one of those opportunities. If you are a company that provides training, you can become a training partner. You can be part of ambassadors and advocates program. For instance, if you are really passionate about RISC-V, you can become an ambassador and help us promote RISC-V in your community. You can join the developer boards program that helps usually distribute boards for free and also discuss the new boards and issues. So issues like boot is one of the items that they touch there from time to time. We have some RISC-V labs. If you want to play with some RISC-V without owning a board, you can get some kind of cloud-like resources from the labs. You can also join the RISE Developers Program Appreciation. Like, it's about source stuff. Like, you can get paid to help them solve a specific problem. Another engagement, so we have the summits. So we just had the one in Paris. We have the one happening in China next month, and the North America one happening in October. Next week, we have in Brazil 2 events. global workshop, RISC-V Open Workshop, RISC-V Brazil. We have RISC-V World RISC-V Days, happening in August. So if you want to participate on the RISC-V World Days, go to our table and talk to Laurie. She can explain about that. And also, so here, more engagement opportunities. This week we have the mini summit that we're going to discuss about the Yocto and RISC-V a little bit. We also have a learning session on one of those LF learning sessions. So that's all. So as you saw, there's a lot of opportunities for you all to help us make RISC-V better. So again, just show up, raise your hand, and help us make that. So thank you very much, folks. So questions. Well, I think we have time for 1 or 2 questions if you will. We are over time. Go ahead.
What is the RISC-V laptop that you have? I'm curious.
So this is I believe this is a 4-core or octa-core, not recall. It's running Ubuntu. So you can play with this. So if you go to our table, you can play with this. So it helped me. It can do anything another laptop can do. Of course, there is a gap. I believe for RISC-V, one of the major gaps is on browser optimization. So because everything today requires a good browser. So if you have a poor experience there, that still affects you. But anyway, that's one of the bottlenecks that should be fixed here. But anything else should work. So for presentation, for doing your emails, you can get this and start to work. So yeah, it's not the fastest laptop in the world, but solves a bunch of problems. More questions? I believe one more question. Go ahead.
All right. Certification.
Yeah.
This is a new concept for me.
Yeah.
What does that mean in terms of the RISC-V community? Like you get your chip or your SoC gets a sticker, your RISC-V certified?
Yeah. Essentially, yeah. So there's going to be the set of tests that I believe essentially is going to be developed as open set of tests. Then you can run your design against those tests. And if you pass, you can get the, I believe, RISC-V certified, something like that. And then that helps on the branding and selling a product that's compliant. They ensure that your product is compliant with RISC-V extension and you are delivering what's expected. So, but that's under the development. So if you are willing to understand what's going on right now, just join the CSC meetings and understand. Because really, they are reorganizing CSC right now and discussing how the test should be executed, how the test should look like. Everything is under construction. So
TBD right now.
it's TBD, but it's evolving because that's a need. It's evolving fast.
But that's the goal, is to have
Yeah,
the
you
sticker.
get the sticker, get the stamp, say, yeah, I'm compliant with the ISA. That's the end goal.
Yeah. Okay, last question.
Go ahead.
Okay, so the ISA, will it have a release schedule?
Yeah, in fact, we did a cleanup this year. Andrew Orman did that, removed all unratified specifications from that. And we are trying now to do that on a ratification basis. Essentially, every month we have the board of directors meeting. And every time we have the board of directors meeting, we need to put a specification for their approval. Once that's approved, that should now start triggering a new release. So ideally, in a perfect world, we should have one new release every month. But we've only...
That's too fast.
But but when I say release, a new version with the ratified extension, maybe it's going to take up more time than that. But that's a cadence of adding new stuff, right? We need to ensure that every time we ratify something, it is part of the main ISA and get delivered, so you can consume that as quick as possible.
So, like, I compare it to like the C++ standard.
Yeah.
Right? Like, there's a new C++ standard every 3 years. And,
Yeah.
you know, originally, like, you know, it was supposed to be like, you know, it would alternate. One would be like kind of a minor bug fix piece, and then the other, the next one would be like a major.
Yeah, there's a discussion, even if they, trying to adjust that sentence that I said, it's not just about releasing every month, but grouping a good number of specifications. Let's say we have this amount of extensions, they justify a new release. Maybe they're going to do that. Again, another topic that's open, that's under discussion, because we didn't have that before. We are releasing every quarter. new version that I say. Looks like that's not the best model. Maybe this is more quick model will help us, but we don't know. So okay, the first step was taken, cleanup. That was done by Andrew, and now we have a clean ISA. But now we need to move forward and decide what should be next, and what the cadence and how things are going to happen. So again, you see, everything is moving, it's happening right now. Yep.